Hello guys, this is Akash. Welcome back to Nursery with Lecture YouTube channel. In this video, I am going to explain circles, which is a part of conic sections. And I already explained that we are going to start the geometry portion. I already completed the straight lines and pair of straight lines. You can check it out in the playlist section of Nursery with Lecture. And in this Elevate batch, the next chapter I am going to discuss is conic sections, that is circles. And I will discuss from basic to advanced. And this is a one shot, and I will revise everything so that you can easily catch the concept here, and I will explain the entire concept within 1 hour to 1.5 hours only, so that you can get the valuable session from this video, so that you can practice later. And after doing this session, I'm not discussing any PYQs here, only the entire concept will be discussed here. And while discussing the concept, if it is needed, I will discuss some numericals so that you can grasp the concept, so that at your end you have to practice the PYQs. I will discuss the entire concept here, and first of all I will discuss what is circle. What is circle? Circle is the locus. The circle is a locus of a point which is moving. Circle is a locus. What I explained, the circle is a locus which is moving at a constant distance from a fixed point. Constant distance from a fixed point. It is called as circle. So if you assume this is suppose this point is a fixed point, and if there is another point which is at the distance d, or you can define as r, and if I move the point in such a way that its distance does not change, the distance is constant. And if you see, and if I plot the entire points like this, you will get the distance at any instant is same, that is the distance is r, 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 and r, and r. And if I see this figure what I formed now, this figure what I formed is called circle. So what is the definition of the circle? The definition is it is a locus of a point which is moving at a constant distance from a fixed point. So if suppose this is a point and this is a moving point, if I make this distance as a constant and I move along this axis, and the distance is not changing, the locus which you are getting is called circle. It is called circle. And at circle, the fixed point is called center, and the distance which you are dealing is called radius. This is a center and radius. And now we will discuss the different forms of circle. Different forms of circle. There are so many forms of circle. That is the circle. Why there are so many forms? There are so many forms because the center has different formats. Center has a different formats. So in order to explain this, I can take examples. The center has different formats. That is, the center can be 0, 0. The center can be first quadrant and second quadrant, third and fourth. The quadrant can be anything. So if the center is 0, 0, how the circle look like? The circle look like this one. So this is center 0, 0, and this is radius. The radius can be anything. The radius is not the matter here. The main thing is center. If the center is origin, how the equation of circle looks like? The equation of circle looks like is x square plus y square is equal to r square. How I got this equation? Suppose I am taking x comma y as a point, and I know the distance from origin, it is radius. So just I equated the distance, that is x square plus y square is equal to r, and x square plus y square equal to r square. So like this I got the equation of a circle. And if it is the origin, if the center is not the origin and the center is x1 comma y1, then how the equation is changing? The equation is just changing x minus x1 whole square plus y minus y1 whole square. X minus x1 whole square and y minus y1 whole square. Like this it is changing. Yes. So x minus x1 whole square plus y minus y1 whole square is equal to r square. That's it. So here if we see from this equation, what is the center? It is x1 comma y1. And now, and the radius is r here. The radius is not changing. Now the general equation I will discuss. What is the general equation? General equation of circle. How the general equation of circle looks like? The circle equation is x square plus y square plus 2gx plus 2f5 plus c is equal to 0. This is a general equation of the circle. From this circle, if I want to find the center, what I have to do? I have to divide. The center here is minus g comma minus f. That is, I have to divide the x coefficient by 2 by minus 2 and y coefficient by 2, that is minus 2. If I divide 2g by minus 2 and 2f by minus 2, what I get? I will get minus g comma minus f, and this minus g comma minus f is a center. So this is a shortcut. And what is the radius? In order to find the radius, simply take r is equal to root of this center square, that is g square plus f square, and this constant is minus c. You have to separate the minus c. So this is called as radius. Suppose if I give example, that is x square plus y square plus, and remember in the circle equation the a and b values, that is if I compare ax square plus by square, the coefficients a is equal to b is equal to 1, it should be satisfied. That is, both the coefficients should be equal. If both the coefficients are not equal, what you can say, this is not the circle. So x square plus y square plus, if I take example plus 5x plus 4y plus 3 is equal to 0. Suppose this is a circle equation. What is the center? How to calculate the center and radius here? Center and radius. What is the center? The center and radius. The center here is just divide the x coefficient by 2 by minus 2 and y coefficient divided by minus 2. What I will get? I will get minus 5 by 2 comma minus 2. This is the center. And what is radius? The radius is simply root of the center square, that is minus 5 whole square plus minus 2 whole square plus we have to subtract the constant, that is minus 3. So at final what I got? I got root of 25 by 4 plus 4 minus 3, and final if I solve this, I will take LCM 4, I will get plus 16 minus 12. So it will be I think 35 41 minus 12. So it will be, if I subtract 10, I will get 31 I think 29 divided by 4, root of 29 divided by 4 is the answer. So I will solve again, that is root 29 by 2 is the answer. So the center here is, center is equal to minus 5 by 2 comma minus 2, and radius is equal to root 29 by 2. So like this you have to solve. And now I already said there are different forms of circle equations. So now the diameter form, that is diameter form. What is the diameter form? The diameter form is, suppose this is the point x1 comma x2, and this point is that is x1 comma y1, and it is x2 comma y2. Suppose these are all the diameter ends, and this is the circle equation. If I assume this as a circle equation, this is the diameter. The diagram is not clear. You can think the diagram, this is not the actual diagram. The actual diagram looks like this, I think. That is x1 comma y1, and this point is x2 comma y2. If I join these two, suppose this is a circle equation, assume this is a circle equation, these are the diameter ends. How to find the equation? Suppose this is the center. The center can be anything. What we can do? We can simply take the coefficients x1 and x2, and x minus x1 into x minus x2 as one equation, plus y minus y1 into y minus y2 is equal to 0. Like this is the equation of the circle when two diameter ends are given. How I got this equation? I can find the center here. What is the center? x1 plus x2 by 2 and y1 plus y2 by 2, and I can find the distance between these 2 points, and I can do half of the distance, x2 minus x1 whole square plus y2 minus y1 whole square. Yes, and by 2 if I do, this is a radius, and if I substitute the center and radius, that is x minus x1 plus x2 by 2 whole square plus y minus y1 plus y2 by 2 whole square is equal to r square, that is x2 minus x1 whole square plus y2 minus y1 whole square divided by 4. So this is the equation. This is the equation of circle, you can think. But if I do the simplification, I will get finally x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. So this is a circle equation of diametrons. And now parametric coordinates. Parametric coordinates. What are parametric coordinates? The parametric coordinates are, suppose the equation is x square plus y square equal to a square. In this equation, if I substitute x is equal to a cos theta and y is equal to a sin theta, what I will get? I will get a square cos square theta plus y square, that is a square sin square theta is equal to a square. And if I take a square common, it is sin square theta plus cos square theta is equal to a square. And sin square plus cos square theta equal to a, that is 1. So it will be a square is equal to a square. So like this, I have satisfied the equation. So the what I assumed is correct. So these are the parametric coordinates, that is a cos theta comma a sin theta is a point which is lying in the circle. Suppose this is a circle. This a cos theta comma a sin theta can be any point. This can be a parametric point on the circle. This is important thing. Suppose like this only. Suppose if I assume the parametric coordinates for this is okay, that is x minus x square plus y square is equal to a square. The parametric coordinates are a cos theta and a sin theta. This is okay. But what are the parametric coordinates? Coordinates of x minus h whole square plus y minus k whole square is equal to a square. For this equation, where the center is not origin, the equation changes to, the coordinate changes to a cos theta plus h and a sin theta plus k. These are the parametric coordinates you have to assume. Now, I already said there are so many forms of equations of circles. So now when it is touching x-axis, x-axis, suppose this is a axis of x, suppose the circle is touching, what I can assume? The circle center, this point, suppose this point is we can take a comma 0 or you can take h comma 0. This point will be same, that is h, but the y coordinate will be changing. Yes, so the x will be same here, but there is a change in the y. That is we can think here the radius. If you assume this this circle having the center h comma k, what is main important thing here? Observation, x minus h whole square plus y minus k whole square is same. But what is radius? Is it needed again we have to define r? There is no need to define again, because this radius is equal to the y coordinate, because how much distance we have moved from x-axis is the ordinate, that is ordinate k. So it is a radius only because it is touching x-axis. So I can simply write here k square, the circle which is touching x-axis. And when it is touching y-axis, when it is touching y-axis, how the equation changes? When it is touching the y-axis, let's visualize. This is the circle. This is a circle. If it is touching the y-axis, what is not changing here? The y coordinate will not change. So y will be k only, h comma k. Yes, again the circle equation is same, that is x minus h whole square plus y minus k whole square. But what is the radius here? The radius is how much you have moved to get the center. How much you have moved? You have moved h units. So it will be h square. It is a radius. There is no need to take again r square. Now we have reduced the variable. That is one variable has been reduced and we have taken h square. So this is a simplification we have done. And touching the x-axis, y-axis is completed. Now touching both axes. Suppose this is a circle which is touching both axes. And if you assume this, when it is touching both axes, the center will be same. That is, if I think it is r comma r, it is moving r distance, it is moving r distance. So r comma r is the center, not h comma k. And this is the radius too. So what I can write? I can write x minus r whole square plus y minus r whole square is equal to r square, simply. This is the thing. And this can be anything. Both axes can be touched like this also, like this also, like this also. So what is changing here? The center. If it is in the first quadrant, the answer will be this one. And if it is in the second quadrant, the radius will be minus r comma r. There you will get x plus r whole square plus y minus r whole square is equal to r square. In the third quadrant, you will get both negative. That is x plus r whole square plus y minus r whole square is equal to r square. At the fourth quadrant, you will get x minus r whole square plus y minus r whole square is equal to 0. What is the changing here? Here the radius is r comma r, here the radius is minus r comma r, here the radius is minus r comma minus r, here the radius is r comma minus r. So because of changing the radius, we have changed the equations of circles. It is the touching both the axes. Now let's discuss what is the length of x intercept. What is the length of x intercept? What does it mean? You already know in the straight lines I explained what is intercept. How much length it is cutting the x-axis and how much length it is cutting the y-axis. It is called x-intercept. It is called x-intercept and it is called as y-intercept. Yes. Now, what is the length of x-intercept in the case of circle? Suppose this is the axis and this is a circle. This is a circle. How much length it is cutting x-axis? The circle, how much length it is cutting? This length, it is called x-intercept. And there is no need to prove this one. We have to just remember the result, that is the length is equal to length of x intercept is equal to 2 root g square minus c. And what is the length of y intercept? What is the length of y intercept? Simply take this circle and what is the length it is cutting? It is a length of y intercept. And what is the answer? The length of y intercept is equal to 2 root f square minus c. 2 root f square minus c. This is the thing you have to remember. Now, position of point, very important. This will repeat in circles, parabola, ellipse and hyperbola. You have to remember each and every concept which is discussed, in circles. It will repeat in parabola, it will repeat in ellipse and it will repeat in hyperbola. So if you understand the every concept, that is what is the point with respect to circle, you will understand what is the point with respect to parabola. Same thing will be for hyperbola and ellipse. So now I am going to discuss the point, that is the position. That is the position of point. How the point is positioned with respect to circle. Suppose I will draw one big circle. Suppose this is a circle. Assume this is a circle. Yes. In this circle, how many possibilities are there for the point to be located? The point can be inside. The point can be on the circle. And the point can be outside the circle. 3 possibilities are there outside the circle. So how we can decide the position of a point? Suppose the point is x comma y. How to decide? And we know the circle equation S. And one more thing, this is a notation. It is very important to remember. S is equal to x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is a circle equation. This is a notation S. And when we substitute the point, when we substitute this point, that is given point x1 comma y1, it is called as S1. S1 is equal to x1 square plus y1 square plus 2gx1 plus 2f(y1) plus c is equal to 0. According to this S1, we will decide whether the point is inside on or outside the circle. So when I substitute this point, if this value of S1 is greater than 0, if it is equal to 0, if it is less than 0. If it is less than 0, it is inside point. It is inside point. And if S1 is equal to 0, it is on the circle. And if it is greater than 0, it is outside the circle. Outside the circle. Like this you have to think. That is, when the point we substituted in the circle equation, if the result is greater than 0, it will be outside. If the result is less than 0, it will be inside the circle. If the result is equal to 0, it is on the circle, because the point is satisfying the circle equation. It is very important to remember. Now we discuss the position of point. Now what is the position of line? Position of line with respect to circle. Now what is the possibilities? Again we will discuss the possibilities here. Suppose let's assume this is a circle equation. Yes, suppose this is a circle equation and suppose this is a center. There are 3 possibilities. The circle, the line can intersect the circle, the line can just touch the circle, or the line does not intersect the circle. There are 3 possibilities. So what is the main thing you have to understand? The position of a line with respect to circle can be 3 types. That is, it can be just touching, which is called as tangent. It can be non-intersecting. It is secant, that is it intersecting, or you can say it can be intersecting line. intersecting line. So there are three possibilities. So with the respect of radius, I can decide now. I already said what is the, suppose ax plus by plus c is equal to 0 is the line equation, and the circle equation is s equal to ax square plus b, sorry, it is not x square. Once again, it is not ax square. It is x square plus y square, because I already said the value of a and b will be, in the case of circle, it will be 1. So x square plus y square plus 2gx plus 2f5 plus c is equal to 0. In the J mains, it has asked that ax square plus ay square, and one circle equation is given. What is the value of a plus b? So a is equal to 1, b is equal to 1. So a plus b is equal to 2. So you have to remember how the circle is formed. That is, the values of a will be, a and b will be 1, 1. You have to understand. And this s is equal to x square plus y square plus 2gx plus 2f5 plus c is equal to 0 is the circle equation. Now, with respect to this circle and with respect to this line, we have to discuss. And for this, what is the center? That is minus g comma minus f. And I already said how to find the distance. How to find the distance between a line and a point. What is the distance? Suppose minus g comma minus f. I want to find the distance from the line ax plus b, by plus c. What I have to do? I have to just substitute minus g plus b of minus f plus c divided by root of a square plus b square. Yes, this is the distance, and distance is called distance from line. Distance from line. And what is the radius here? If I assume this as radius r, if this is the radius r, if the distance which we calculated here, from the center to the line, if this distance is equal to r, if the distance is less than r, if the distance is greater than r. Now here, these are the three cases. If the distance which we calculated from the point, that is center to line, if it is equal to the radius, then it is the line which is touching the circle. So it is a tangent. And if it is less than r, that is, the radius is greater than the distance. So if the radius, this radius is greater, this value is greater than this value, so the line will be intersecting, because this distance, suppose this is d, this d is less than r. Yes, because the r is this entire thing. So in this case, the line is intersecting line, that is secant, that is intersecting line. Intersecting line. And if it is greater than r, that is the distance which we calculated is greater than r. Suppose if I think this one as r and this as d, the entire distance from the center to line, it is r plus d. So it is obvious that r plus d is greater than r. So in this case, the line is non-intersecting. The line is non-intersecting. So I have discussed what is the main thing here, and one more thing. Suppose x square plus y square plus 2gx plus 2fy plus c is equal to 0, and there is a line which we can discuss as y equal to mx plus c, suppose. And if I want to find the relation between the constant c and the tangent condition, how can I find? What the relation is? C square is equal to a square into 1 plus m square. This is a relation. If c square equal to a square into 1 plus m square, it will be, this is a tangent condition. But the actual condition is derived with respect to this one only, that is intersecting, non-intersecting and tangent, with by evaluating the radius and evaluating the distance from the center from the line. This is a tangent condition. Now, equation of tangent, very important. This will repeat in circles, parabola, ellipse, hyperbola, same concept, but just the equations will be changing. This one is equation of tangent in various forms. Equation of tangent in various equation of tangent in various forms. What you will get? You will get the equation of tangent in various forms as, first one is point form. First one is point form. That is, suppose x square plus y square plus 2gx plus 2fy plus c is equal to 0 is a circle equation. I already said, and the notation for this is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is a notation. And what is the point form? The point form is the value, that is S11, you can say. The S11 is simply find the main thing here, that is the point is x1 comma y1. This we have to convert this form, that is the x square is converted as xx1, and x is converted as x plus x1 by 2, and y is converted as y plus y1 plus by 2, and y square is converted as y by 1. Simply substitute these forms into the equation, you will get the answer. And here x1 x2 is, that is x1 and y1 is the point which is given, so this is called as point equation. And when I substitute these transformations, what I will get xx1 plus y by 1 plus 2g of x plus x1 by 2 plus 2f of y plus y1 by 2 plus c is equal to 0. S11 is equal to xx1 plus y by 1 plus 2 will gets cancelled, g of x plus x1 plus 2 will gets cancelled, f of y plus y1 plus c is equal to 0. This is called tangent equation in point form. Tangent equation in point form. Suppose x square plus y square equal to 4. This is a circle equation, and the point given is 3 comma 2. We have to find the tangent equation. How we can find the tangent equation? Just simply find this xx1 plus, because we have to transform x square as xx1, y square as y by 1, and x as x plus x1 by 2, y as y plus y1 by 2. So xx1 plus y by 1 is equal to 4. What is x1? This is 3x plus 2y minus 4 is equal to 0. This is a tangent equation at the point 3 comma 2. How we find it? We find it as a point form. Now the second format is parametric form. Parametric form. Parametric form. I already discussed the parametric coordinates. What are the parametric coordinates of circle? It is a cos theta, comma a sin theta. Yes. So simply substitute the actual point in this equation. That is this one. That is x square plus y square is equal to a square. Suppose this is the equation. Simply substitute this parametric point in this equation. That is xx1 plus y by 1 minus a square equal to 0 is a circle equation. Now here x1 and y1 is a point format points, but here these points can be replaced as a cos theta comma a sin theta. So simply substitute these points here. What you will get? You will get x into a cos theta plus y into a sin theta is equal to a square. And if I cancel a here a, I will get x cos theta plus y sin theta is equal to a. This is called tangent equation in parametric form. This is called parametric equation. This is called parametric equation. Parametric equation, that is the tangent. Tangent in parametric form. Tangent in parametric form. Tangent in parametric form. Yes. Now the third form is slope form, which is very important. Slope form. How the slope form is? The slope, suppose the equation is x square plus y square is equal to a square. What you have to do? The slope is y equal to mx plus c. Suppose this is a line. What is the c condition here? Y equal to mx. Already discussed. In order to become the tangent, what is the c? C should be c square equal to a square into 1 plus m square. Yes. So now simply substitute the value of c. C will be a root 1 plus m square. So this is the equation in the slope form. That is a tangent equation in slope form. Here m is the slope of the given line, and that is the required line, and this a is the radius. Tangent equation in slope form. So the slope form is completed and the tangent concept is completed, and it is very important in the point form and parametric form. The point is given, that is x1 comma y1 and a cos theta comma b a sin theta. These are the points. So you will know the point of contact of the tangent, that is this point will be this one or this one. But in the slope format, you didn't know at what point it is touching the circle. So in order to find that point, it is very important. The solution is plus or minus a square m by c comma minus or plus a square by c. Here what is c? C is this one, that is c will be a root 1 plus m square. So the actual formula will be plus or minus a square m by a root 1 plus m square comma minus or plus a square by a root 1 plus m square. Yes, this is the answer. So in order to find the point of contact in the slope format of the tangent, at what point it is touching the circle, you have to use this formula. Whereas it is a point in order to calculate. That is, in order to calculate the point, we are using this one. So this is the point of contact. Now very important concept, that is tangent from external point. Tangent from external point. In the point format, what I said, the circle equation is given and there is a point given x1 comma y1. It is on the circle and in this point only we have to make the tangent. But what if there is a circle and the point is outside x1 comma y1? How to find the circle equation? The circle equation can be found by simply the circle equation is equal to y minus y1 is equal to m into x minus x1, and this is a point. If I make this as tangent and this tangent, these are perpendicular, and this is r, and it is very obvious the point can be calculated here. This is an external point, that is y minus y1 equal to m into x minus x1. So we have to find the slope, that is the point is given and the slope we have to find. How we can find the slope? We can find the slope just by mentioning the point here, that is the external point is given x1 y1 and the r is given. So simply we can find by using this relation, that is equal tangent equal to y minus y1 equal to m into x minus x1. So this is a tangent from external point. Now comes the important discussion, that is equation of normal. What is equation of normal? The normal equation is in the case of circle, it is very important. The normal equation is the line which is passing through the center. Simply, if a line is perpendicular to tangent and it should be perpendicular to the tangent. Suppose this is a tangent, this one is tangent, and the line should be perpendicular and should pass the center. That's it. If the line is perpendicular to tangent, yes, the tangent is the line is perpendicular. This line is perpendicular, and then it is called as normal. If the line is perpendicular to tangent at the point of contact, then it is called as normal. The main important thing is this is a tangent and this is a normal. If it is perpendicular, then this is a normal, it is okay. But in case of circle, what they are saying, in circle normal always passes through the center. So if the tangent point of contact is given as 3, 2 and the circle center is given as 2, 3, there is no need to find another equation of normal. Just simply solve these 2 points and find the equation. How you can find? Y minus y1 equal to y2 minus y1 divided by x2 minus x1 into x minus x1. If you solve this one, if you solve this equation, you will get the equation of normal. In the case of circle, it is very important that what is the normal? The normal is a perpendicular of tangent at the point of contact. But in the case of circle, the normal always passes through the center. This is the one short trick you can think. That is, if the tangent is given and the slope is given and the center is given, you can directly find the answer. Yes. Now there are results. Now there are results. The results are, we can say that what is the length of tangent? And what is power of point? These are just results you have to think. What is the length of tangent and what is the power of point? What is the length of tangent? Suppose this is a circle and the point given is x1 comma y1. Yes, suppose x1 comma y1 is a point and I have to calculate this length. This length I have to calculate. This length can be calculated as L is equal to root S1. What is S1? S1 is substitution point x1 square plus y1 square plus 2g x1 plus 2 y1 plus c is equal to 0. This is the after substituting point, what is the value we got, and the root is called length of the tangent. And what is the power? What is the power value of point? That is the power of point. The power of point is S1, simply S1. That is the L square. The length square is equal to power. And in this case only I want to discuss the chord of contact. Chord of contact. What is chord of contact? Suppose there is a circle. P is a point. In this point I have drawn 2 tangents and the two tangents will intersect at 2 points, and if I join this line is called chord of contact. Chord of contact. And how I can find this equation with the help of this point x1 comma y1? It is simply t is equal to 0. What is t? T is a tangent, that is a transformation. That is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. This is a transformed equation, and this is equal to 0 is a required chord of contact equation, that is t equal to 0. So we have to just remember the notation. What is the length of the tangent? It is root s1. What is the power point? It is s1. And what is the chord of contact? It is t is equal to 0. T equal to 0 is the tangent equation also. But the main difference between the chord of contact and the tangent equation is, in the tangent equation, the point which you are substituting is on the circle. But in the chord of contact, the point which you are substituting is the outside the point. This is a difference between the chord of contact and tangent equation of the slope form, that is a point form. Now, chord with given midpoint. Another result. Chord with given. What is a chord with a given midpoint? Suppose we have to calculate the chord with a given midpoint. This is a circle, and this is the chord, and the midpoint of this chord is given. Now it will become the equation t is equal to s1. T is a transformed equation. I already explained this is tangent transformed equation. And what is s1? Simply substituting the point x1 square plus y1 square. What is the value you are getting? And equate to t. This t is equal to x1 gives that chord with the given midpoint. The midpoint here, the value is x1 comma y1. This point should be substituted in the circle equation, and you will get an answer that should be equated to this transformed equation tangent. Yes, but this t is not the tangent. This is the transformed form of circle. I will write here so that you can understand. S is equal to x square plus y square plus 2jx plus 2fy plus c is equal to 0 is a s. And what is s1? S1 is a point x1 square plus y1 square plus 2gx plus 2fy1 plus c is equal to 0. And what is t is equal to 0? T is equal to 0 is x1 plus y1 plus 2g of x plus x1 by 2 plus 2f of y plus y1 by 2 plus c is equal to 0. This is a t is equal to 0 equation. And what is t is equal to s1 equation? Entire t, that is x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0 plus c is equal to s1. So what is the point s1? Simply write this point here. This is t equal to s1. And next, pair of tangents. Pair of tangents equation. Pair of tangents equation equal to s into s1 is equal to t square. This s into s1 is equal to t square is a required pair of tangents equation. This s into s1 is a required pair of tangent equation. Yes. And next I will discuss the director circle. And we already know s and s1 and t square. This is a pair of tangents equation. That is, what is, suppose the point x1 comma y1 is the outside point, and I have to draw two tangents, and it will meet the circle at 2 points, and I have to write that equation of two parallel, that is a two pair of straight lines equations, that is the two tangents equation. The equation is s into s1 is equal to t square. S into s1 is equal to t square. Next I will discuss the director circle. What is a director circle? Locus of the point of intersection of perpendicular tangents. Suppose we have drawn two tangents to a circle, and if this is the perpendicular, if the point of intersection becomes a perpendicular, then it is a director circle. And with this point of circle, if I draw the another circle, this is called as director circle. This is called director circle. Yes, this is called as director circle. And what is the radius? The center will be same. The center will be same thing. That is x1. That is, we can think of x0 comma y0. But the radius is root 2 times the actual radius. Actual radius is r. So the radius of director circle is root 2 times r. Root 2 times r is the radius of the director circle. Now there are some important results. There are some important results. There are some important results which you have to remember. That is, what is the length of the chord? I will draw the diagram so that you will understand. Suppose this is a circle, and by intersecting the circle there is another circle, and suppose if I do not denote the points, that is D, this is L equal to root S1, and this is A point, and this is B point. This is this one is R. This one is R because it is the center, and this is M. By observing the diagram, we have to see what is the length of chord. Length of chord is equal to 2RL divided by root of r square plus L square. That is, this length will be RL divided by root of r square plus L square, and this length will be RL divided by root of r square plus L square. Yes. So by adding these two, we will get 2RL divided by root of r square plus L square. And what is the triangle AOB area? OAP area. OAP. What is OAP? This triangle area is half RL. And what is the area of triangle? That is a parallelogram. PAOB. If I draw like this is PAOB, and this parallelogram area will be RL. You have to think the results. That is half RL. And what is the area of triangle OAB? OAB is OAB. This triangle is R cube L divided by r square plus L square. This is area. And what is the triangle area of PAB? PAB area is PAB. This area, this big triangle area, it will be RL cube divided by r square plus L square. These are the important results you have to remember. 1 second, guys. I think the charging is over. Let it be. It will complete the lecture. Yes. Next 15 minutes, the lecture will be completed. Now I will explain the relative position. Relative position of two circles. Very important concept. In this concept, there are so many PYQ questions. Suppose this is a circle and this is a circle. This circle is S1, this circle is S2. Let's assume these are two circles. How many possibilities are there? The first possibility can be these two circles will intersect. And the second possibility is this circle just touch. This circle just touch. This circle just touch. Or you can make more simple. That is in the order I want to write. That is the reason I am rubbing again. If I write in order, it is easy to remember for you. So this is suppose the first possibility can be, what is the first possibility? The circles will not intersect. This is the first possibility. The second possibility is circles will just touch. And what is the third possibility? The third possibility is the circles will intersect. And what is fourth possibility? Fourth possibility is circles circles will be touching inside. And what is the fifth possibility? The circles will be inside. The circle will be inside. In these possibilities, how many tangents we can draw? How many unique tangents can we draw? And here the centers will be C1, C2, and the radius will be R1 and R2. Like this, every triangle we have to name it. That is C1, C2. This is R1. This is R2. This is C1. This is R1. This is C2. This is R2. This is C1, C2 and R1, R2. Now, here it is C1, here it is C2, here it is R2, it is again R2, here it is R1. And the last possibility, here it is C2 and it is R2, and this is C1 and this entire thing is R1. Now, if you see, you by yourself only you can make the conditions. That is, the center distance here. The center distance between the two is greater than R1 plus R2. Yes, this case. And the second case is the center distance is equal to R1 plus R2. Yes. And the third case, intersecting. If the center distance is lying between R1 minus R2 and it is less than R1 plus R2. Yes, in this case. And the fourth case we can think of the center distance is equal to difference of the radius. And the fifth case is if the center distance is less than R1 minus R2. These all possibilities. In the first case, how many tangents are possible? 0 tangents. In this second case, how many tangents are possible? 0. One second. Why I am saying here 0? I didn't see the diagram. It is non-intersecting. When it is non-intersecting, I can draw how many tangents? I can draw nearly 4 tangents. So it will be 4. Here it will be 3. It is reduced because at the point of intersection, 1 tangent will be there and the remaining 2 tangents will be here. So it will be 3. And here it will be 2. Because here, this one and this one. And here it can be 1. And here it can be, in this case here it can be 0 because no tangent can be drawn. Now, this is a position. There is a position of 2 circles. Now comes the important concept, that is length. That is length and equation of common tangents. Length and equation of common tangents. Common tangents. What is the length and equation of the common tangents? You have to understand. What is the length? There are 2 types of tangents. This is a direct tangent. This is a direct tangent, and this tangent is called transverse common tangent. This is direct common tangent. Direct common tangent, and this tangent is transverse common tangent. Common tangent. Yes, and what is the length of the tangent here? Length is equal to root of d square minus r1 minus r2 whole square, because this length is greater. The direct common tangent length is greater, and this L is equal to root of d square minus r1 plus r2 whole square. There is a negative here, there is this addition. So this is a main important thing you have to understand, and this is the length of the tangents. Now orthogonality of orthogonality of 2 circles. What is the orthogonality of 2 circles? You have to understand. That is when we can say the circles are intersecting. This is the intersecting case because it is orthogonality. There is when we can say the 2 circles are intersecting at right angles. That is the 90 degree. We can say when r1 square plus r2 square is equal to c1 c2 whole square. When this is satisfied, because if you observe, this is r1, this is r2, this is the center distance. Like this you have to visualize. And another condition you can derive, that is 2 into g1 g2 plus f1 f2 is equal to c1 plus c2. Here the c1 c2 is the constants in the circles. two circles. And next important concept, that is radial, that is radical center. Radical center. Before radical center, I will discuss the radical axis. What is meant by radical axis? The radical axis is defined in the bookish language like this. The radical axis of two circles is a locus of point. That is, these are the two circles. I will explain. These two are the two circles. And if I draw tangents and if I draw a line, that point should have the common, that this line at any point in this should have a common distance between the two. It having the common distance between the two. If it is satisfied, this axis is called radical axis. Radical axis, and this axis can be found just by simply subtracting these two circles. That is, s minus s dash is equal to 0. Suppose this is s and this is s dash. S minus s dash is equal to 0 is the radical axis. And for touching circles, the radical axis is simply the tangent here. That is, again we have to minus s minus s dash is equal to 0 only. And for intersecting, the chord itself becomes the radical axis. Yes, like this there are some properties. Now I will discuss the radical center. Radical center. The radical center also, the definition in bookish will be like this: the radical axis of three circles. Suppose the radical center, it is saying that there are three circles. This is the circle 1, this is the circle 2, and this is the circle 3. If these are the three circles, we have to draw the radical axis. The radical axis for this circle is, these two circles is this one, and these two circles is this one, and for these two circles is this one. And the three radical axes will intersect. Three radical axis of three circles. Three circles will intersect. Three radical axis of three circles will intersect at we can say at a point. That point is called radical center. That point is called radical center. Like this you have to visualize. And next important concept is family of circles. Family of circles. What is the main concept of family of circles? Suppose there are two circles, and I want to find another circle which is passing through the point of intersection of the two circles, and I want to find this one. What I can do, I can simply suppose this is s1 and this is s dash, and I want to find this circle equation. This circle equation can be found by the concept of lines. That is where I discuss how to find the line which is passing through the point of intersection of the two given lines. How we can find? That is L1 plus lambda times L2 is equal to 0. Same concept here. In order to find the circle which is passing through the point of intersection of two circles, we can write as s plus lambda s dash is equal to 0. This is the concept. And next, and if two circles are intersecting, if one circle and one line is intersecting, and from that point I have to calculate this one. What I can do, again, s plus lambda times L is equal to 0, because this is a L is a equation and s is a circle. So s plus lambda L is equal to 0 is a required thing. And the main important thing is equation of family of circles touching a fixed line. This is a fixed line. At one point, every circle is touching. We have to find that equation. Here it is very important. This question has came in my JEE Mains attempt, but I am unable to answer because I didn't notice this property, but I know this property. So in JEE Mains, in this circle equations, this is the only thing which you cannot visualize. Suppose this is a point. We have to continuously draw the circles. This point having a zero radius. A circle with zero radius can be existed. That radius circle we are writing now, that is a family of circles. That is x minus x1 whole square plus y minus y1 whole square. This is the thing, and it is equal to 0. This is a zero radius equation, And if I equated this one as x minus x1 whole square plus y minus y1 whole square, and this line equation, because it is lambda times plus lambda times this line, what is the line equation? Y minus y1 y minus y1 minus m into x minus x1 is a line equal to 0. So this entire is the equation of family of lines. So like this you have to visualize. That is, I will write again. The line equation is, that is the circle equation which is passing through the fixed point of the in the line. The equation is x minus x1 whole square plus y minus y1 whole square plus lambda times of y minus y1 minus m into x minus x1 is equal to 0 is a required line. You can find the question. I think it is 2022 question. JEE means 2022 question. I think it is June attempt. I forgot the year date. That is 24th June. 24th June question will be there in my attempt only. That is x minus x1 whole square plus y minus y1 whole square plus standard times of y minus y1 minus m into x minus x1 equal to 0. So this is a circles, and after this I want to say this one. The concept is completed. Concept is completed, but at your end you have to practice PYQ. This is the main important thing. I have discussed the entire circles concept, but you have to practice the PYQs of circles. You can practice around 30 questions only, but practice the important concepts like family of circles, and tangent, and normal, and some more important, that is basic circle formulas. That is the different forms of circle. And the next thing is different forms of circles, and next, and results, important results. If we complete all this one, you can try radical, axis, radical center, these concepts, and orthogonality also. These things you can complete after the completion of these things. So first complete this one, and later you can complete this one. So that's it, guys. I have completed the entire concept. After this you have to practice the PYQs only. I have explained what PYQs you have to practice. First, the order should be like this. First you have to practice some basic circle formulas questions, and later you can practice the family of circles, tangent, normal, and results. Some important results are there, you can practice. And up to now, if you like this video, subscribe to this channel and also hit the bell icon, because like this videos I will be going to bring in the upcoming sessions. And I have completed up to now straight lines and pair of straight lines, and the circles has been now completed. Next I will bring the parabola and ellipse hyperbola videos, where you can also learn the concepts of parabola and ellipse hyperbola. And these circles having the weightage plus 4 marks guarantee question will be there in the circles. And the next chapter also very important, that is plus 4 marks will be again parabola, and the ellipse hyperbola also plus 4 marks. This entire ellipse hyperbola will be plus 4 marks. So this is a main important thing you have to understand. That is, for every chapter up to now which we have discussed, there is straight lines having the weightage plus 4 marks, the parabola circle having the plus 4 weightage box, and the ellipse hyperbola combined weightage is plus 4 marks. So you can think every chapter you are getting at least one weight. So you can think that is 12 marks is guarantee from the geometry portion. So you can think how important is geometry portion. So if you want to study, you have to study from straight lines and pair of straight lines, and next complete the circles and parabola, ellipse, and hyperbola. The order should be like this. And after learning the concept from my videos, what you can do, you can just simply do the PYQ practice. And if you want to practice the PYQs also, I will give one link in the description, that is the Change Makers batch of 2023. Change Makers batch, which I designed for 2023 students, JEE students. That batch you can follow, the skip to the last, because in that I have explained the straight lines and pair of straight lines and circles, everything I explained. But the questions I have practiced for you in the last I think 30 to 40 minutes I have explained the questions. You can check it out if you want to practice the questions also. I think I have completed the entire thing. And again, if you have any queries, you can comment it down. comment down in comment section. I will reply. What concept, if you want anything also, you can comment it down. I will definitely make the video in that. That is, if you want any some important specific formulas to be repeated for JEE mains, if you want to revise with me, you can comment it down in the comment section. I will reply to you whether I will do or not, but I will definitely do for you if you want. Because planning according to me will not make any use for you. You have to ask what you need. So if you, when you ask, I will try to make that videos only, so that it will be really beneficial for you. Because randomly making videos will not be very helpful for you. What videos you want, you can comment it down, because I also make the lecture planner according to the weightage of the chapters. But if you want, I have to make any particular chapter, I can even make that also, but you have to ask in the comment section. So after watching the video, whatever opinion you have, you have to comment it down, and whether it is positive or negative, you have to comment it down, because I will improve for my next sessions. And also, if it is positive, I will just take it as a motivation, and if it is negative, and again I will take as motivation, and I will improve my sessions with the help of the content which I am planning. So ask it down in the comments. And if you like this video, subscribe to this channel, hit the bell icon, and also join the Telegram group. I will share the notes there. So that's it for the video. Keep learning, keep going.